Do you want to know what hexadecimal really is and why it would be useful at all? Well, sit tight. I got your back. All right, so hexadecimal. Keep in mind, hex is 6 like a hexagon, decimal is 10. Folks, we're working in base 16 here. All right, so I'm going to help build the intuition of hexadecimal, and I'll tell you a couple of really useful ways in which hex is used. But first, let's build it up first. All right, so hexadecimal. Well, first off, from our normal decimal land, we've got 0 through 9. And then they're like, well, we're not going to use numbers anymore. That's going to get confusing. So let's go to letters. 10 will be A, 11, B, 12, C, and so on and so forth, D, E, and F. 13, 14, and 15. Now you might say, hey, you forgot one. Well, keep in mind, 0 through 9, those are 10 digits. Then we have the 11th, 12th, 13th, 14th, 15th, and 16th digits. Okay, so a little bit of subtlety there. We were going 0 through F, which is 16 characters in total that we're going to work with in hexadecimal. Okay, so let's go through a couple of examples, and then I'll tell you how this can actually be useful. I mean, in and of itself, it's kind of weird and interesting and beautiful. I'll give it that. But it also has, it truly has some uses. All right, so let's say we have, something like, let's say we have something like this right here. Oh my goodness. This is a number in base 16. Don't let it weird you out. There's letters. We know they just represent numbers. Now, what's interesting is each one of these digits has a power of 16 attached to it. Let me go off on a tangent for a moment. Much like, if I have the number 2,129, there are 9 ones, 2 tens, 100, and 2 thousands. You can say, well, this is base 10. And you can just start rattling off. I'm just going to count up from 10 to the 0, then have 10 to the first, 10 to the second, and 10 to the third. We have powers of 10. Why? Because this is decimal. This is base 10. All right? And then we can kind of clean that up from there. So keep in mind, we have ones, tens, hundreds, and thousands, but those are truly just powers of 10s in decimal land. So now we have powers of 16 in hexadecimal land. Okay? Our ones place, we have 9 ones. We have F16s. Now keep in mind that's 15 16s. So as many as possible in the 16s place. And then in the 16 to the second place, the 256's place, we have D, which is 13. All right. Now we can continue to clean this up. Recall, though, this is the ones place. It wasn't just straight up 0, just like this was the ones place. We had 9 ones there. Here we have 9 ones as well. 16 to the 0 is just 1. I have a video on exponents if you need help with it. Please check it out. Then we have 15 times 16. Let's kick it old school and multiply it out, because sometimes people need a little reminder here. We can do the ones by the ones. That's 30. That's 0 ones and 3 tens. 1 times 5 is, it's 1. It's really like a 10 times 5 is 50. And then we have 3 more 10s, so we have 80. And now here, this 1 really represents a 10. We can do 1 times 6. That's 60. 60 in the tens place is really 6 in the hundreds place. 1 times 1, really that's 10 times 10. That's 100. And then you have 6 more. So that's going to put you at 700. What am I doing? What is this guy doing multiplying here? I really don't know. Let's kind of back that up for a moment. Goodness. I think I was like really vibing on the multiplication. Pardon me. We can just do 1 times 6, folks. That's 6. And 1 times 1 is 1. Hey now. That's 240. 16 times 16 is 256. We could have just done 1 less 16. That would put us at 240. Goodness gracious. And then in the 256 place, we have 13 of those. Apparently, I can't multiply so well right now. So now we have 13 256s. That's 3328. So we got 3328 and 240 and 9. So the number DF9 in base 16, that's really just, we line these all up. We've got 3328, 240, and 9. Always right align it. That's 3,577 in base 10. So again, hexadecimal, you have base 16, so you have your powers of 16. Now, you may be wondering, how is this useful? In terms of network addressing, this is very, very helpful. Like for people's IP addresses, they're commonly in hex format, especially IPv6. So those addresses are going to be written in hex. So that's useful. Also, like many file formats, especially binary data, like you might have like images, audio, files, it may be very useful to have various components or structures within them that are going to be in hex. They're certainly useful in like mathematics and cryptography. It's a good way to work with big numbers, like large numbers, make them be a little bit more manageable. It's also super useful in terms of hashing. It's good if you have like a checksum to make sure that everything is done correctly in a cryptographic hash. That's useful. So base 16 shows up in a lot of nice applied computer science realms. Also, machine code instructions are typically written in hex if you have the pleasure of taking an assembly language coding extravaganza there. Also, like colors can be written in hex. You maybe have seen, something like, maybe you've seen like hashtag FF0000. That would be red. That's written in hex. Now it doesn't sketch you out so much. You're like, oh, those F's, those are some 15s, multiplied by some power of 16. Even like ASCII coding, like character encoding, that is hex. So it shows up a lot in computer science. And so when you see these letters, don't let them weird you out. Just know that whatever digit you're on, you're nearing the upper bound of that digit. 10, 11, 12, 13, 14, 15. If you had a 16 there, you could go up to the next digit, just like we usually do in base 10. So hexadecimal is very, very interesting. And so notice how we did kind of go off on a tangent and just looked at decimal to make it make more sense. So just keep in mind, let's say we have something like AB19F. This is in base 16. Just keep in mind, this is just a bunch of powers of 16. We have 16 to the 0, 16 to the first, keep going, 16 to the second, 16 to the third. You know what? I'm gonna get crazy here too. Let's have a 0 in there. I think that's important. We have a 16 to the fourth, and then we have a 16 to the fifth. So each one of these digits is just a power of 16. So the F in the ones place, that means we just have 15. And then we have 9 times 16 to the first. We have 1 times 16 to the second. I'm not going to clean this up. I'm just going to show you the representations. B, keep in mind, A puts us at 10, so B puts us at 11. And that's the 16 to the third power. The 16 to the fourth power, there is nothing. So you don't have to write that because 0 times 16 to the fourth is just 0. And then A, recall that's our 10. We have 10 by 16 to the fifth. And we could clean this all up if we wanted to see what it was represented in base 10. Now, on the flip side, let's say